Hello and welcome back. In this video, we will finally get started with Reagent. Right now we have a blank page. The goal of this video is to render something into this page. So let's get started. So the first step is to install Reagent dependency into our application. So let's go to Google and type Reagent GitHub. Let's click on that link and it will lead us to the GitHub page of Reagent. And this is where the Reagent project lives. If you want to go through the source code, how Reagent is implemented, you can go ahead and do it yourself. And also this library is very well documented. So if you have time, I would highly recommend you to go through the source code as well as the documentation. But what we want to do is we want to go to this link over here. So let's click on this link, and what we want to do is copy this vector and let's paste it here. And then you need to restart the server. This is because Shadow CLJS won't automatically download the dependencies for you. You have to restart the server to download all the new dependencies. Now that we have Reagent in our application, the second step is to require Reagent. We will look at two namespaces, reagent.core and the reagent.dom namespace. Now the last step is to get Reagent render something into the DOM. Reagent.dom has this function called render, and this render function is basically the entry point for a Reagent application into the browser's DOM. So this function accepts two arguments. The first argument is what that gets rendered in the browser. In Reagent application, this is always Hiccup. Inside this Hiccup, we have a symbol called counter, and this is a Reagent component, which we will define shortly. And the second argument that the render function take is we need to specify a DOM node. So let's go ahead and define these two parts. First, let's define our counter component. Counter is going to be a Reagent component, and Reagent component are ClojureScript functions that return Hiccup. We will go over Hiccup in a while, but to put it simply, it is a virtual element that describes the DOM. In our example, we are returning a div that with the string counter in it. Now that our component is defined, let's define the DOM node. So the second part is to query or find the element, the DOM node, in which we want to put our component. So in order to do that, we can use the getElementById function, and this function accepts a single argument, which is the ID of the element. And when you invoke this function, what this function does, it goes through the document, the HTML element, and it'll try to find an element with an ID of app, right? And once it finds that DOM element, it will return that DOM element or that DOM node. And if you go to index.html in public directory, you'll see that we have defined div and gave an ID of app. Let's save this file, and the next thing we should see is the counter string rendered on the screen. And let's inspect this element. We see that our Hiccup was converted to DOM element, and also notice that this element is inside the div with an ID of app. This is what the render function does. It mounts our virtual DOM inside the real DOM. Awesome. So you have written your first Reagent application. So let's look at Hiccup, right? So Hiccups are basically ClojureScript vectors. And the first element of Hiccup could either be a keyword or a symbol. If it is a keyword, then it is an HTML element where keyword is the tag of the HTML element. For instance, we have a keyword of div. So this translates to the div tag from HTML. Second, it could be a symbol, right? If the first element is a symbol, Reagent will treat the vector as a component. And this we already saw in the render function which we got from reagent.dom namespace. The first argument that it accepted was and Hiccup. And what was in the Hiccup? We had the counter symbol. Now, symbol in Clojure and Clojure script are just data, right? Symbols are bound to some value, and this value can be anything. In this example, the counter symbol is bound to a reagent component. So the first element can either be a symbol or a keyword. The second element of a Hiccup is a map. It represents the attribute of the element. And one thing to keep in mind is that this map is optional. So this attribute map may be omitted. Let's look at our first example, class. So let's look at the first method, and that is using vectors. Vectors can store multiple items, right? So in this case, we can define one or more different classes. So let's look at a simple example where a vector has only one class. Now, this is not really that useful, right? It is more useful when you have more than one, when you need to define more than one classes. So let's give two more classes, right? Now you see that this div has 3 class strings instead of 1. So this pattern can also be useful if you want to display classes based on some logical condition. Let's say you have some nav bar and you want to show a different style based on the current nav bar that you are on, the active nav bar, or something like that. Now let's look at the second method, and I think second method is much more similar than the first method. So the second method is passing string as a value rather than a vector. So we can rewrite our previous example like so. So instead of passing the vector, we pass a string of container. So there's one more way to write this classes. We can write it in a css.syntax like so. Now if we save it, everything works. If we go to HTML, we see that we have the class container and the div. We can also add multiple classes in this matter. Let's add some random classes such as some or other class. And now if we go and check HTML, this div has 3 different classes. Personally, I love this syntax. It is a very concise and expressive way to write classes. With this method, I don't have to write a map to define classes, right? Anyway, this is Hiccup attributes in a nutshell. You can also add other attributes such as DOM events, and you can pass handlers, functions as a value to these events, but we will see that in the next upcoming videos. We will not go through this in this video. Okay, so this is good. We have defined the first element of the vector, the Hiccup vector, the second element. Now let's look at the third element of Hiccup. So the third value in the Hiccup must either be string literals representing child text nodes, or Hiccup vectors representing child nodes. So far, we have already seen the first version, the string literal example. So we have a div with a class of container, and we have a string called counter. Now let's look at how we can represent child nodes. Let's write an h1 tag and give it a value of counter. So here's an example of Hiccup vectors representing child node. Simple, right? If we check our inspector, we should see h1 tag inside the div tag. Now let's write another child element, a button, and let's give it a class of button and button increment and a string of the plus sign. Eventually this button will increase the counter value. Awesome. Let's also define a variable called counter state. For now, we'll give it a value of 0, and we will use this value inside the h1 tag. And in the h1 tag, we're using the string function to concatenate the counter string with the value that we just defined. Right now, if we click on our button, it does not do anything. This is because we haven't registered any on-click handlers. And we will see how to do that in the next video, in which we will learn about React's synthetic events, and we will also learn about Atom, which is ClojureScript's way of managing mutable state. Thank you and see you in the next video.